Okay, so today we are going to do the next section, and it is going to focus on graphing linear equations using the intercepts. So when you think about a coordinate plane, we have an x-axis and a y-axis, and an intercept is the point where the line would cross either of those axes. So the x-coordinate of a point where the graph crosses the x-axis would be an intercept. So for example, let's say I had a graph going like this. The x-intercept would be this point right here where that line crosses the x-axis. And then the y-intercept would be this point right here where the line crosses the y-axis. Now, the x-coordinate, because it's always going to be on the x-axis, would have some numerical value for x, and the y value would always be 0. On the other hand, the y-coordinate of a point where the graph crosses the y-axis, or our y-intercept, will always have a 0 value for x and then some numerical value for y. Now, the good thing about using this method is that we don't need to get the equation in function form or solve for y, which is usually an added step that we have to do before we actually do our graph or find points on the line or any of that. So in this case, if you recall, standard form is ax plus by equals c, where a, b, and c would be numbers, and b and a would not be 0 to get the equation. Now, in this particular case, standard form is nice because I can easily plug a 0 in for x and get my y, but I could also plug a 0 in for my y and get my x, and now I have 2 points on my line. They're 2 very specific points, the x-intercept and the y-intercept, but all you really need is 2 points to be able to graph a line. So for example, if we're going to find an x and y intercept, so if we look at this equation here, we have 7x minus 3y equals 21, and I want to find the x-intercept. So you would substitute 0 in for y because every single point that is an x-intercept has a y-coordinate of 0, and then we would solve for the x. So this is what it would look like. 7x minus 3 times 0 equals 21. Of course, the 3 times 0 would cancel out, leaving me with just 7x equals 21. And then I could solve for that x, getting 3. So I know my x-intercept is going to be 3, but we really want to focus on writing that as an ordered pair because the intercept is really a point on the line, and x equals 3 could be an equation of a line, so we don't want to confuse the two. Now, when we go to find the y-intercept, we would substitute 0 for x and then solve for the y. So this time we would put the 0 in for the x, which of course would cancel out this first part, leaving us with negative 3y equals 21. Then we would finish solving for y, and we would get negative 7, which would make this intercept 0, negative 7. So now we have 2 points that we can graph on a coordinate plane, and if we draw the line through those points, then that would be the equation, or that would be the graph of our line. So let's practice finding some of these x and y intercepts. So for number 1, if I want to find my x-intercept, I'm going to put 0 in for the y. So it's always the 0 goes into the opposite variable of the one you're trying to find. So that would cancel out. So I'm left with negative 4x equals 24. Divide by the negative 4, x equals negative 6. Now remember, even though you kind of know now where is it going to cross the x-axis, you need to write this as an ordered pair because we're finding that point on the x-axis where the line's going to cross through. So now to find my y-intercept, I'm going to put the 0 in for the x. So that part will effectively cancel out. I'm left with 3y equals 24. which means y equals 8. So that point, the y-intercept will be 0, 8. So let's try the next one. Okay, so the next one, finding my x-intercept. I'm going to put 0 in for my y, which of course cancels that portion of the equation out. I'm left with 5x equals 15. I divide by 5, giving me x equals 3. So my x-intercept would be 3, 0. Now I'm going to do my y-intercept. So this time I'm going to put my 0 in for the x. Now in this case, that part cancels, but I still have a negative in front of my y. So I'm going to have to divide by a negative 1 to get the y completely alone, which would give me negative 15. So my y-intercept is 0, negative 15. And then the next one, I'm going to find my x-intercept by putting in the 0 for the y. Now this one looks a little bit funny because it's not in standard form. So it's already in that function form, but we can still use this method. It's just a little bit easier when it's in standard form. So now for this one, because I do have a 0 here on the other side of the equal sign, and I need to get the x by itself, I would have to add my 3, giving me 3 equals 1/5 x, and then I would multiply both sides by that reciprocal of 5, or 5 over 1, and that would give me x equals 15, which means my x-intercept is 15, 0. And then now I would find my y-intercept. So now even though the x-intercept is a little bit more difficult when it's in this format, the y-intercept is actually a little bit easier because the y is already by itself. So when I put the 0 in for x, that part just cancels and I'm just left with my answer. Y equals negative 3. So 0, negative 3 would be my y-intercept. So let's look at what do these intercepts look like on the graph and how can we easily identify them. So to find the x-intercept, you would look to see where the graph crosses the x-axis. So looking at this graph here, now this one they're trying to kind of be a little tricky, and notice that the boxes or the grid here is increasing by 2 boxes or 1 unit. So this is actually like a half, and this is actually like 1.5. Same thing when we're going up. This is a half, this is 1, this is 1.5. Same thing in the negatives. So just be careful because that if you're just counting the boxes, you'll have the wrong answer here. Okay, so we're looking for the x-intercept. So where is this line crossing my x-axis? So we can see that there's a negative 2 there. So my x-intercept is going to be negative 2. However, we want to identify this as a ordered pair, so it would be negative 2, 0. Now to find the y-intercept, this will be the point where it crosses the y-axis. So to find the y-intercept, where does the graph cross the y-axis? So we can see that that's right here at this little spot that I just highlighted in blue. Now, even though it's up 2 boxes, that's really 1 unit, right? Because each box is representing half a unit. So the y-intercept would be 0.01. So this point here is 0, 1. And this point over here was negative 2, 0. So those are my x and y intercepts respectively. So let's do it again for the next problem. So what is our x-intercept here? So looking on my x-axis, where is it crossing through? So my x-intercept in this particular question is 3, 0. Remember that x-intercept always has a 0 for the y. And then the y-intercept, which is going to have a 0 for the x value. So we're looking for the y-intercept. Where is the graph crossing through on the y-axis? Down 1, 2. So it's 0, negative 2. So now we're going to use the finding these intercepts to actually graph an equation. So if this is my equation here, you want to graph it. and label the points where the line crosses the axis. So the first step would be to obviously find those intercepts, because now you'll have 2 points that you can graph on your line. So to find my x-intercept, I'm going to take this equation and I'm going to put the 0 in. I'm going to put my 0 in for the y. So 3x plus 2 times 0 equals 6. I'm left with 3x equals 6. So x equals 2, which will make my x-intercept 2, 0. Then I will repeat the same process for the y-intercept, but this time, of course, my 0 is going in for the x so that I can solve for the y. So I'm left with 2y equals 6, dividing y equals 3, and then my point is 0, 3. So once I have my 2 intercepts, I have these 2 nice points that I can plot. I'm going to go ahead and plot them. So 2, 0 would be on my x-axis right there. My y-intercept is 0, 3, so that would be right there. And then, of course, I would draw a line through those points. Like so. Now, once you draw this line, if you want to check to make sure that you did do this correctly, it might be important to do that, because if you're only graphing your line based on 2 points, even if one is correct, if one is wrong, your whole entire line will be wrong. So all you would have to do is look for another point that would have pretty easy coordinates. So maybe this one here, which is -2, 6, or maybe this one down here. Well, my line went a little crooked. I think it's supposed to come through here. Let me fix that just so we're not too confused here. Okay, this point here was, oh, actually I did have it right. Okay, was 4, -3. It's a little easier if you draw your line straight. But anyway, if you want to check any other point that appears to be on this line, assuming your line is drawn straight. So I'm going to check -2, 6. So I would use my original equation, which was up at the top there. So 3x plus 2y. So 3x plus 2y equals 6. Now, if I plug in this -2 for x and this 6 for y, it should work out if my line was correct. So -6 plus 12 equals 6. So that checks out. So let's do this again. So we're going to graph this equation by finding the 2 intercepts. So my x-intercept, which I know is going to have a y value of 0. So I'm going to do x minus 1/2 times 0 equals 1. So x equals 1. So that point is going to be 1, 0. Then I'm going to find my y-intercept, which I know will have an x value of 0. So 0 minus 1/2 y equals 1. Now this is one of those times I have -1/2 y equals 1. I'm going to multiply both sides by my reciprocal, which in this case is -2, giving me y equals -2. So now I can plot my y-intercept, which is 0, -2. And then I can plot my x-intercept, which was 1, 0. And I can draw my line. Right, now once again, if you kind of look through and see where it's maybe crossing in some other spots, you could check one of those points to make sure that you did do it right. So let's say I want to check this one here, which is 3, 4, right? So if I'm going to check that point, I would have 3 minus 1/2 times 4 equals 6. 3, half of 4 is, oh, I'm sorry, is a 1. 6 bucks. And that does equal, so we checked it out. All right, and that's it. So that's how you graph a linear equation using the x and y intercepts.